Okay, we're going to talk about plate boundaries in this video, and with each plate boundary we have very specific land features and processes that are associated with it. So we're going to take a look at those things today, and those are our objectives with this video, is to know each of those land features, each of the very specific processes that happen with that. There's three main types of plate boundaries: divergent, where they move apart; convergent, where they come together; and transform, where we slide past each other. So those examples are all listed here in this picture, and then we're going to take a deeper look at each one of those. So divergent boundaries are where plates are moving away from one another. There's two main types: oceanic-oceanic and continental-continental, and they're just what they sound like. With oceanic-oceanic, we have two oceanic plates moving apart from one another, which is what we see here with the oceanic spreading, and then continental-continental is where it's the continents that are moving apart from one another. Doesn't matter which example you have. In both examples, the characteristics of a divergent plate boundary is that we have a whole lot of heat. This is at the top of a convection current where convection is rising. We're going to have volcanoes because, again, the plates are moving apart, so we have spaces for magma to come up to the surface, so that's going to create volcanoes. And then earthquakes. That's really going to be common with all of the plate boundaries, because as plates are moving, that's going to cause the earth to shake. So let's start first with the oceanic-oceanic divergent. These are where two oceanic plates or pieces of crust edge are moving apart from one another, and these create an oceanic ridge. So that is the feature that is associated with an oceanic divergent plate boundary, and you need to know that. Oceanic ridge are basically volcanic mountains that are created down on the seafloor. An example of that we've been talking about is the Mid-Atlantic Ridge, right there between South America and Africa. And when we take a look at a map of the Atlantic Ocean and what that looks like, you can see that it's fairly shallow over here by the United States, and it gets deeper, and you've got these other little peaks around here, but then we have this huge long mountain chain. Then we have continental-continental divergence, and these are where two continental crusts are coming apart, and the feature that's created there is called a rift valley. This is different from an oceanic ridge because it's obviously on a continent, but these are basically volcanic mountains that are created on land. And an example of that is Iceland. Okay, the Mid-Atlantic Ridge goes straight up and goes up to Iceland, and that's still the Mid-Atlantic Ridge, okay, when it's in the ocean, but when it becomes on land, now we have a continent that's there, and we call this a rift valley, and that is a volcanic mountain chain. And if you go to Iceland, or if you've ever seen pictures of Iceland, you can actually go there and notice that all of these little red triangles here are volcanoes, because that's where magma is coming up to the surface. With convergent boundaries, these are where plates are moving toward one another. They're coming together. And when this happens, you have these two plates meeting, and most often we have subduction that's happening. And then you should write down this definition. Subduction is when the more dense plate gets pushed below the less dense plate. So the densities of the plates is really important here. We have three types of plate boundaries that come together. We have when an oceanic plate meets another oceanic plate and they come together, oceanic and a continental, and then continental-continental. So let's take a deeper look at each one of those. Starting with the oceanic plates when they come together. We don't know which plate is going to be denser in general, but whatever oceanic plate is more dense is going to be pushed back down underneath the other plate. So here we have an oceanic plate, and here we have an oceanic plate. I know this oceanic plate is more dense because it's the one that's being pushed under or subducted into the mantle. This creates an oceanic trench where it is pushed under. So it starts to drag some of this other crust with it and gets pulled under and is recycled back into the mantle, meaning it's going to eventually melt. This also forms an arc of volcanic islands, so that's another feature that's created. We have an oceanic trench and a volcanic island arc. So as this stuff melts, it starts to get really hot, but it's still close to the surface. So some of that really hot material comes up as volcanoes, and then they're not volcanic mountains, they're islands because they're still in the ocean, because remember we have two oceanic plates. So we have this volcanic island arc that is then created. An example of this would be the Aleutian Islands that are off the coast of Alaska. We have a big Aleutian Trench in this red area marked here. Okay, that would be associated with where the subduction is happening. And then just off the side of it, we have the volcanic island chains, which are the Aleutian Islands. And again, right next to where that subduction is happening. The Marianas Islands are another example. So we have the Marianas Trench, and that's where the deepest trench on Earth that we know, the deepest place that we know. And then right next to that, we have the chain of islands that are associated with that. So this is a very common occurrence, the feature that is associated with oceanic convergence. Next, we have oceanic continental. This is very, very similar. We have the oceanic plate and the continental, but now we always know that the oceanic plate is going to go under. It's going to be the one that's subducted because it's always going to be more dense. But again, material gets heated, recycled back into the mantle. Some of that heated material rises right up to the surface. But now instead of a volcanic island arc, we just have volcanic mountains. Notice still that we do have the trench from land being pulled down. So we have the oceanic trench and we have the volcanic mountains now. Examples of this would be the Andes Mountains and the Cascades Mountains. The Cascade Mountains are just off the coast of California, and we have the Pacific Plate being subducted right underneath that. That's going to give us volcanic mountains like Mount St. Helens, Mount Rainier, all of those volcanoes that are around Washington and Oregon. The Andes Mountains, again, are right on the coast of South America, and that's where, along the coast of South America, the Nazca Plate's being subducted, and we see volcanic islands all along this coast of South America. And again, here's the Cascade Range. We can see that we have this plate being subducted, and we have Mount St. Helens, Mount Adams, we have the Cascade Mountain, volcanic mountain range that's being produced. Finally, we have continental. Now with continental, usually if there is a less dense crust, that's one's going to be pushed under. However, both of them are very light crusts, so neither one of them really want to sink down into the mantle. So one might be pushed down a little bit, but mostly they're just going to crumple up. Kind of like if two cars were to crash into one another, they're just going to crumple. One's not necessarily going to go under the other. So what that produces are these really tall mountains from this collision happening, but they're not volcanic because we don't have any melted material. So of the three convergent plate boundaries, the continental is the only one that doesn't produce a type of volcano. Instead, it just produces very large mountain ranges. An example of this are going to be the Himalayan mountains. So when India moved up and collided with another continent, the Himalayas were formed right along that. And you can actually see we have a flat area here, we have a flat area here, and then we have this huge mountain chain that's created, and Mount Everest, the tallest mountain on our planet, happens to be in there. So you can tell that continental convergence is really going to cause a major thing to happen. You can even see this from space. This is an image from space. So here you have India, here you have your other plateaus, and then this is all the crumpling that's happened. And you can actually, this blue line obviously was drawn on there, but that is the plate boundary. So you can even see the plate boundary shows pretty well where the mountains should be, and Mount Everest is right in here. And these don't look that tall, obviously, from a space picture, but these are very, very tall mountains. Okay. The Ring of Fire. We talked about that a little bit with our last homework, but the Ring of Fire is basically plate convergence. Okay, we have volcanic islands and volcanic mountains being created. So here we have the United States, and we actually have the Cascade Mountain Range as a part of it. We have the Aleutian Islands. We have all of these islands around Japan. Japan is one giant island. Volcanoes on the edge of South America. So we have a ton of these different volcanoes, and then we also have all these blue areas are trenches that are created. So what that tells us is this area here, this Pacific Ocean, is being subducted. It's being surrounded by convergence, and so it's being subducted on all sides. And so sometimes you'll hear it called the Ring of Fire or the Pacific Ring of Fire because it's around the Pacific Plate. And eventually Several of you have asked if eventually we'll have another Pangaea being created. Eventually this plate will be completely subducted and these continents will actually move together. So that tells us that the Pacific Ocean is actually shrinking while the Atlantic Ocean is growing. And then finally we have transform plate boundaries. These are where plates aren't really moving towards or away from each other. They're just sliding past one another in opposite directions. And so these are just going to cause earthquakes. We're not going to have any volcanoes with this or any mountain building, just very strong earthquakes. So where we have very strong earthquakes around the world are usually along plate boundaries, and more specifically transform plate boundaries, where we have these fault lines. So the fault line is the feature that's created with the boundary. We don't have any mountains or trenches or volcanoes or things like that, just the fault line with increased amount of earthquake activity along those places. Best example of a transform boundary is going to be the San Andreas Fault in California, and this is an image, again a real picture of the San Andreas Fault, and you can see that fault line. We'll talk more about transform boundaries when we get into earthquakes. And that's our very detailed story of plate boundaries. Thanks for listening.